This is the Empower Podcast, released December 2nd, 2018, episode 418, an interview with Josh Datko. Welcome to the Amp Hour. I'm Chris Campbell of Contextual Electronics.
And I'm Josh Datko from Cryptotronics.
Welcome, Josh. How you doing?
Doing well, Chris. Just put up a Christmas tree. Things are going well.
All right. 'Tis the season. Yeah. Things are moving along. It'll be 2019 before we know it.
Yeah, it's crazy.
So what is Cryptotronics and what's your background? Maybe we should start with how we met and then we can kind of go back.
Oh, yeah. There. Yeah, well, I think we met at Black Hat this year. But yeah, to go back, so I own a company called Cryptotronics. It's a consulting, contracting security, mainly embedded security company. I'm the owner. We have 4 employees. Been doing it for 5 years. We had our 5-year anniversary just like a week ago. So I was pretty happy about that. Yeah. Before that, I'm a graduate of U.S. Naval Academy. So I, started off thinking I was going to be a career naval officer. Did that, was on a submarine for about 5 years. Left the submarine, worked for a defense contractor, making little black boxes for the government. Then I was in the reserve, so I got recalled to go to Afghanistan to help the Army because apparently the Army needs the Navy's help.
I was going to say a lot of subs in the desert there, huh?
Yeah, exactly. Well, so my joke is that I did my mission. The Taliban has not yet developed a submarine force, so I can claim mission accomplished.
That's right. That's right.
Yeah. So I don't know.
That's a healthy slogan to use. It's not been overused anywhere else.
Right. Yeah, has no negative connotations. So I was recalled to go to Afghanistan. That was kind of interesting. And then I got out for good. So that was kind of like, I'm not doing that again. And moved to Colorado where I live now. And then, started Cryptotronics. So then we met at Black Hat, and I have helped Joe Fitzpatrick, who's been on your show before, I think, and with his hardware hacking class. And I can't remember why you were there, but somehow we ran into each other, and I recognized your voice.
I was helping Colin with his.
Oh, that's right.
Class.
Yes.
Helping is a in quote marks, but similar. I think you actually are able to help Joe. I was just kind of observing Colin.
Oh yeah.
So. Yeah.
Well, sometimes I just
past guest of the show.
Oh yeah, right, yeah. So those guys are great. So my goal in helping Joe is to not have him get any negative comments on behalf of me.
Right. So in the reviews and everything.
Exactly.
Yeah. So okay. So first off, you're our first military guest, and that's super cool, actually.
Yeah.
After 400 some shows, so I would love to hear more about that kind of stuff too. But because of the leap. The leap to embedded and security, it seems odd to me, but I'm guessing that's somewhere in the black box thing that you'll get to.
Yeah, I had kind of it's kind of been an interesting path to get here. So in the Naval Academy, I was kind of like really book smart more than any other kind of smart. So I ended up doing pretty well. I graduated like 45th in the class of 900 something. And then did a lot of, so I did that. So I was able to do this program called Trident Scholar, which allows you to spend the last year kind of doing undergraduate research, of which I did kind of cryptography and more like application of cryptography with cool. Like aircraft. Yeah, the paper is embarrassing to read now, but it was fun.
Military stuff has a lot of, a lot of the cryptography stuff's interesting, and I think the internet is one main thing. But I think military is a huge consumer of military intelligence. All those communities are consumers of the high security type of, understanding what cryptography and everything like that. So.
Yeah, especially from a operational perspective. So there's a lot of, the term is OPSEC in operational security. So there's a lot of that, as a operator in the military, you don't necessarily go into some of the details. I mean, now if I would have gone back, I would be way more geeking out into like, let me open that thing. Let's see the circuit board, which is generally bad to do.
Yeah,
they don't like it. Yeah. So that's kind of got the start in. So I was a computer science undergrad, but I had an interest in security. Then, so the Naval Academy even if you're an English major, you graduate an engineer. So even English majors, even English majors are taking circuits, like Circuits 101. And so you can't graduate without actually having some electrical engineering, some thermodynamics, some mechanical engineering, some weapon system engineering. Everybody has to take this. So computer science is considered a group 2. It's in the middle. It's not like electrical engineering, but it's not, history. So I took, 2 semesters electrical engineering, like a weapon systems class. And then I went into submarines. So submarines, you have 5 choices at the Naval Academy, basically. You can go into Navy surface, such as surface ships, the kind of traditional Navy. Okay. Submarines, you can become a Navy pilot. And then the Navy actually essentially has operational control of the Marine Corps. So the other 2 options are Marine Corps Air and Marine Corps Ground.
Interesting.
So, I had no interest in being a Marine. So that kind of eliminated those. The pilot option is a commitment of like 10 years after you get your wings. So you're looking at a minimum commitment of 12 years in the military. So I was like, that's kind of long. The surface ships, you do these tours. So like, in your kind of summers at the Naval Academy, you have this like internship job and you go to other parts of the Navy. So I went to the surface ship down in Florida, as being decommissioned. And it was just like, I can't do this. It was just like, just look around and like, I get this. So I went to did a submarine. So you go on a submarine and like the first thing they do is they put you in charge of driving. So the submarine is basically a plane under the water. It has planes that kind of control how it's moving under the water. And the most junior people in a submarine are the ones who physically have control over those planes. So my first day on a submarine, they put me, they're like, here, right, lost of confidence. So they're like, the first day on a submarine, they're like, I'm, I don't know, 19 years old. They're like, hey, sit on here. You're actually going to be driving the sub.
Oh my God.
Like, don't worry, we're right behind you. I'm like, oh, okay. And so, we start to dive, so there's a whole diving procedure. You have to, obviously, close all the hatches and all this. It's a big procedure. But when we start diving,
you're above the surface?
We're above the surface. Okay. Exactly.
Okay.
Yeah. So the submarine, when it's on the surface, just a small, like the whole draft. So the draft is like how deep the sub goes is like 30 something feet, but you only see maybe the first like 10, like when it's on the surface. Most of the sub is actually underwater, even on the surface.
Right, like an iceberg kind of, right? Exactly.
So the first time, my first experience on a submarine, I'm on those planes. We start the dive, and so you push down on the diving planes and the submarine starts to go down. Well, water starts coming in. Like I start getting wet, right? And I'm like, okay, I saw some movies before, and I'm like, generally water in the sub is a bad thing. And I'm kind of like looking around to see how other people are reacting, because I'm like, I don't know. I don't want to be the guy flipping out if this is just normal. And then I felt a lot better when everyone's like, quick, get the paper towels. And so I was like, okay, this must be minor. Okay. But yeah, that was so obviously after that, I was like, yeah, this is what I want to do.
Oh man, that's great.
Right. Yeah. Yeah.
That's amazing. The first day they just put you right in. I mean, like that's
yeah. So you really jump right into it. So, but the other thing that's unique about going subs is that you spend the first year after graduation basically going to graduate school, for a nuclear power. So all officers on a submarine, with the exception of the supply officer, has gone through nuke power school. So what that means is you do 6 months of power school down in Charleston, South Carolina, and it's like 6 hours of classroom instruction per day. And again, you take another electrical engineering classes. You take more thermodynamics, chemistry, nuclear physics. Like you take
thermodynamics with big implications.
Yes, yeah. So, and it's like it's kind of like a military instruction. So, like they have these. If you get like less than, I don't know, like your GPA is very closely monitored, and if you get less than like a 3.0, you have to stay there longer and study, and it's pretty painful.
Yeah.
And then so you do 6 months of schooling, and then you do 6 months of operating on a prototype reactor, which is like
a simulator almost.
No, it's a real. There's one in Charleston and there's one in Schenectady, New York, and these are like real reactors. They let trainees just operate. And
where does the power output go though? I mean, like, is it just driving like a turbine or something?
Yeah, it's just going. I mean, it's going nowhere. I mean, it's essentially. Okay. I mean, it's not. They're not moving. The one in Charleston is actually an old submarine that was converted. I can't remember the type. Schenectady is like a different. So I went to Charleston. The Schenectady reactor is kind of like a test reactor, and so it's basically like a dummy load.
Okay. All right. Yeah.
But you do that for 6 months, and then you go to your sub, and then you do that all over again. So
Yeah. Well, and real quick, what do you actually, so like on a test unit like that, what is it mostly about? Like, so maybe you could give a brief reminder about what nuclear power, what you're really doing there for
so
me and others,
really,
I guess.
yeah, no worries. Yeah, basically you're boiling water.
My stuff's like based on like Bond movies and like
no worries,
maybe like Hunt for Red October. Were those diesel subs or were those actually?
No, those are nukes. Yeah.
Okay. It's mostly movies for me.
Yeah, that's cool. So basically, you're boiling water is the whole point. So the submarine reactor system, really at a high level, there's two main loops. There's a primary loop, and so there is water that is going through the reactor, and it goes through these main coolant pumps. And this primary loop is a closed loop, and then it is connected to a secondary loop, which is non-radioactive water. And the heat transfer occurs in these steam generators. So if the primary goes through a steam generator, basically heats up the secondary loop, and then that secondary loop is now steam, and then the steam can drive the turbines, which provide power and propulsion. And
so it's almost like an HVAC system as well, where you're basically heating. Well, I guess a boiler is like that, right? Where you usually have a heat exchanger. You don't necessarily send all the boilers actually send water all the way through like radiators. I don't actually know.
Yeah, I can't. So if you went to the surface Navy, you would have a boiler, and so I can't. I've been out for like 10 years, so some of this stuff is painful, regress memories. Yeah.
Okay.
But yeah, so basically the idea is you're trying to, the primary reactor is boiling water in the primary coolant, and then transferring it to the secondary plant where it can provide propulsion and electricity and all this stuff. So that's the kind of basic idea. Yeah.
Okay. And so so you were studying the electronic side of things as well, right? I mean, I understand you know everything, but
so it was like so mainly my background there is kind of like power EE. If you were like going to so that was computer science undergrad.
Delta and Y.
Right. Exactly. So the electronics, so the electronics comes in the instrumentation and control systems, which I had always kind of like, did well in that kind of like area of study. So I just kind of like that stuff. And so there's, where that comes into play is the like rod control system and some of the sensors, they're basically industrial
control systems. Yep. Cool. Wow.
So yeah.
What kind of power levels are we talking here too? Because that's what always boggles my mind.
Oh yeah, so I'd have to go back and look it up, but I mean it's like megawatts, and it's got a couple of zeros, associated to it. Yeah,
right. It's just it's such a tight package, and those things can just go for like months and months and months underwater. It's amazing, like they're amazing machines.
Yeah, right. So like you can, the only thing you're limited to is basically food. So the submarine, has a reactor, so it's I think every 30 years. I was in a Los Angeles class. I think every 30 years, the older ones had to get refueled. So if you've got fuel for 30 years, you can make your own oxygen. Yeah, you make your own oxygen with an oxygen generator. So it brings in water and just splits hydrogen and oxygen. You can also suck in air through like a low pressure blower via snorkel mast. So we can get air.
Okay. Like near the surface, but not necessarily.
Exactly.
You don't have to go all the way up. You're saying. Okay.
Yep. You go close, and then you can raise masts and antennas, and like a periscope or the snorkel mast, or some other mast.
Wow.
So we get air.
It's like a spaceship almost. Like pretty close.
So the longest I was underwater, I think, was about 6 weeks. It was we did a around the world deployment. Yeah. Wow. We left Connecticut, went through the Mediterranean, went through the Suez Canal to India. Then we did Japan, and then we went to Hawaii, and then we went through the Panama Canal, back through the Caribbean, back home to Connecticut.
Holy crap.
Yeah.
Okay. So, and I'm sure that there's some sensitive stuff here. So, feel free to just leave out whatever's not allowed to be said.
Yeah.
But like, how much of the time do people know you're there? I guess I don't quite.
Oh yeah. So there's like, so we were an independent operations boat. So we kind of did our own special things. And they are, people, I would say, generally know where you are. Like, obviously the Navy knows, like, oh, hey, there's a submarine doing this thing over there. But like the exact, they don't have there's not like a GPS tracker
Yeah,
that can
right.
operate.
Well,
Yeah.
you're not like with the AIS system. You're not like transmitting a beacon and saying, "Here I am." Right?
Yeah. So AIS. I mean, so you can receive AIS, and it's kind of and you can transmit, although the Navy generally doesn't. In fact, last year there were two collisions in the like Pacific area where there were two surface ships. And you can actually see, you can go back and watch the AIS data and see the collision. And
oh my God, that's crazy.
So So I mean, I remember using AIS on the sub. Yeah.
Cool. Okay, man. So then, how did you not go crazy after 6 weeks underwater? I mean, like, it's super tight quarters, right? And I know that we're not talking about electronics yet. I feel like I should prompt people. Like, I'm so interested in the other stories here that, like, the electronics, we're gonna get there. But like, the other stuff is amazing.
No, I have a list. So I was, I had to go through my wife and make this list of stories. Some of them are electronics related. So I tried to make some good ones here. But yeah, I mean, I think I had a pretty comfortable living space. I mean, my feet and my head touched in my bed. And I'm 6'3", and I could
not
rotate
each other,
on my
though.
side.
They touched the bunk walls. They didn't touch.
Yeah, it was kind of like
you
a
weren't
coffin.
folded in half.
No, it wasn't folded in half. I mean, it's the equivalent of sleeping in a coffin. So I was an officer, and I eventually had one of the staterooms, which is quite a big room. And so just describe how big it is. So you open the door, and you take one step, and you could take one step, and then you're at a desk. And you take another step, and you're at 3 beds. I mean, so that's quite a lot of room, really. I mean, you could fit so much in there.
So much,
yeah.
And sounds like my college dorm.
Yeah, exactly. So that's actually quite a comfortable living arrangement, because some of the junior enlisted, they actually have to sleep on top of the torpedoes, and there's not enough. So there's not enough beds there's like 120 people on a Los Angeles class, and so there's this term called hot racking. So a rack is a Navy bed, and it's 3 people for 2 beds. So, one guy gets out, and the other guy, just kind of rotate. Yeah. Hygiene problems get treated very quickly. They get self-corrected. It's a very tight feedback loop.
I hear you guys use those sleeping sacks too, that like everybody has their own like sheets, but it's not like,
yeah. Well, there's yes, the enlisted, I think, right. You can just tear off the sheets and put the other one. I mean, it is an actual bed. You're not like sleeping on top of the like actual torpedo. I mean, you are literally on top of the torpedo, but there is like an actual bed there.
Wow.
So when you do, the problem is when you do weapons evolutions where you have to move torpedoes around, like if your bed is over there, you just like don't sleep. So,
whoa. Okay.
Yeah.
It's crazy.
So
all right. So let's hear some of these stories. Let's hear some of these stories then.
Oh yeah. Okay. Well, I mean, so the thing is, like, the military is like kind of not like real life. So like you are in it, and it's just these crazy situations. And at some point I realized, and I just kind of stepped back, and I'm just like, this is not real. Like there's so much, like you have to really get in the head mindset of just like, I need to do this job. I'm doing this. Like nothing makes sense, but I need to do this. And I think that's like a problem for me. Like I would think, like, I actually didn't follow orders well, which I think is why I ended up leaving the military. But like some of these, I would just find myself in crazy things. So like one of the, and then there's some things I didn't like, I just went into. So, when you're doing a sub thing and you're on the periscope, you're supposed to like do this weather observation. So, you can imagine a sub out there doing its thing, and, we're tracking where the submarine's at and all this stuff, and you're on a periscope. And so basically the way the periscope works is it's just, optical mirrors that bring in light, and just kind of like you would think, as you probably are imagining a periscope. So one of the things the officer does is he's up there, and you do a weather observation, and you say like, hey, the sea state is this. I think the waves are this high, et cetera, et cetera. Well, one of the things I was supposed to learn was all these different cloud types. So, there's there's a lot of I mean, if you Google like how many cloud types there's lots of clouds.
Cumulonimbo. Vernacular.
Right. So I knew one, which was cumulus. And I think eventually I learned stratonimbus, which are like the hot. So cumulus are the big puffy ones, and stratonimbus are these like thin ones. And so I would get on the periscope, and then they'd be like, Lieutenant Datko, weather observation. And I'd be like, oh man, I don't know my clouds. And so I would, I would look at the clouds and be like, cloud type cumulus. And so the periscope, there's every like time. A video. Yeah, every time we'd just be like, because like you're trying to do all these other things. Like when you're the officer of the deck, you're like driving the submarine only with your voice. So you're the only person looking out the sub, and you're trying to keep like all these you're trying to do a lot in your head. And like the last thing I'm really worried about is what the clouds look like. So, but anyway, so like the captain and everything would be like, Lieutenant Datko, that is clearly not a cumulus cloud. He'd start getting berated, and I'm like, man, this just sucks. I don't know clouds. But I figured out a trick. So like I was saying, the light is coming through the periscope, and then it gets sent to these basically cameras. Well, what you could do is on the periscope, I could turn off all the cameras. And the reason I would want to do that is that I would get more light to my eyeball, right? Because some of the light is being
bad eyes. You got to do
exactly
it,
right.
Yeah.
So I would go up there, and they're like, so everyone would be snickering. They're like, oh man, here comes Lieutenant Datko. We're gonna make him do a weather observation. He's gonna yell at. And so I was like, okay, I got this, right? And they're like, oh, Lieutenant Datko, request a weather observation. I'm like, okay, here we go. So I would, do the waves and all that stuff. And then I would say, turning off the cameras for better, like, so I could see better, basically. I can't remember what I said, but something like that. And then I would say cumulus, right? And then everyone was like, whoa, why'd you turn off the cameras? Like, you can't do that. I'm like, no, it's safety of ship. I can't see,
Yeah.
And
gotta get that light, man.
Right. So then this other guy would come on after me, and he'd be like, no, clearly they're like stratonimbus. And I'm like, well, when I looked at it, they were cumulus. So clearly, so anyway,
weather's changing
so then
fast.
People,
yeah,
they did change fast. So I would always do things like this.
Got it.
So I was also the radio officer. So this is kind of where I got some involvement in electronics. I was the radio and crypto officer. So help manage all the crypto on the sub and all the radio communication. Well, one other thing, the sub would do is we'd make these IP radio networks. So we'd have like IRC. And in fact, we use
within the sub or
external? You'd be on a connection, over satellite, and then you'd be able to get to it's just like a normal internet. It'd be the military version of the internet. But you would be using IRC, which is like Merck, like MIRC.
Right. Yeah.
And so Merck had this thing, and so this is we're using this on a submarine. It's just a completely like civilian, freeware program.
Yeah, right.
And and you had this button where if you right click someone's name, you could it did this macro, and it would say slaps with a big brown trout.
Oh yeah,
and right. So one day I was the radio.
Back.
Yeah, so I was the radio officer, and one day we're like talking to our squadron, who's basically in charge of the 4 or 5 subs, and one of the radio guys accidentally hits this button, and it says radio guy slaps squadron officer with the big brown trout, in the chat. And so I get called I get called to the captain's stateroom, and he is this was a few years ago, and then these guys, some of these older guys didn't really get computers so well, so he's like, hey, Lieutenant Datko, why are you guys slapping people with big brown trouts? And I'm like, no, sir. He didn't type. He's not actually slapping them with a trout. He
right. He's not taking time to probably type that all out.
Right, right. He didn't. He's like, you know how bad this makes us look if he goes around. And I'm like, sir, he didn't. But he didn't. It was like
encrypted military operations.
Right,
Lieutenant. Oh my god.
Yeah. So I had to and so the other time, so we're gonna have to you're gonna have to cut me off because sometimes But so this other time I'm getting another chat related thing because I was the comms officer. And we had Microsoft Net Meeting was the main. I don't know. Somehow we're using Microsoft Net Meeting, and they were again.
Amazing that's what you're using. So you're setting up just these full things over satellite, and it's just and then it's just consumer software pretty much.
I think it's all changed now, but before the Navy kind of had its head around maybe we should actually have programs that are custom for
bespoke stuff.
Yeah. Right. So Microsoft Chat had this feature where you could change the text into comic mode. And so you'd be chatting and you would say, I want to do comic mode. And then it's like a dog and a cat talking to each other. And sometimes a bunny rabbit comes in. Right. So I'm we're doing a tomahawk strike exercise. So this is it's hey, submarine, shoot a missile here, fire 3 missiles, this is a serious exercise.
Some big stuff. Right.
Yeah. Right. We're not actually shooting the tomahawk.
Okay. I was going to say, is it actually doing that? But it's not.
Right. No, we're pretending. You do a lot of pretending. So if you like pretending
war games.
the military is perfect for you. Cause sometimes you don't actually get to shoot real things, but, so we're like pretending to fire these missiles. And, I was like, I'm looking at this chat program. I'm like, oh, it's got this comic mode. And, I was probably bored. And so I clicked it and I was like, oh man. So now it's like, here's the dog. And the dog is like, submarine, shoot 3 missiles, like barking at the cat. And the cat's like, Roger, shoot 3 missiles. And I'm like, oh, this is so funny. I mean, this is like what. And so again, the captain comes by, as he tends to do. And he's just like, what is this? Like, because he thought that everybody could see, that everyone was seeing cats and dogs. He thought like I changed it, right? He didn't quite get the concept. There's like a client local thing.
Right.
So he's like, why are they a dog? Why are we a cat? Like this, what are you doing? And I'm like, sir, I didn't actually pick the cat. It's like, it just picked that for me. He's like, just change that back. Right. So I would do some of these kind of, okay. So
I'm sure we're gonna pepper more of these stories in, but I would actually.
Okay. I should stop. Yeah.
Okay. So we'll come back to that stuff. I'm sure.
Okay.
So So as like the cryptography and like communications type officer, how much how much interaction was there? Is it mostly like using it as an off the shelf item almost, or is there like what happens if things break down? What happens if things go awry? Like, is there a troubleshooting process for that stuff, or is it mostly like a reboot kind of thing?
Yeah, so there's like a lot here. I'm going to be err on the very conservative of saying, but I would sure. A submarine generally is meant to be very self-sufficient. So there is a large amount of redundancy built into basically everything the submarine does. And so whether that's from communications to like independent power supplies, it's kind of the equivalent of like designing things for like, which I've never done, but like, things like for like satellites or rad-hard where you just have voting logic and these kind of things. So, a lot of the submarine is when the systems are engineered to have this kind of fault redundancy or there's enough equipment on board to be able to repair it.
Oh, so like spares and whatever. I
exactly.
You wouldn't be as restricted on like weight as you would be in a space application, but space for sure.
Yeah, I mean there's only so many where you can stick things like on a sub. Right. But generally like having one of anything is just like if there's no backup for a part on your PCB, you're like, well, this is the only part. That makes people nervous.
Ordering one resistor from DigiKey, not a great idea.
Yeah, right. Yeah.
You're probably that's the one that you're gonna squeeze too hard. It's gonna go ping, ping right across the lab. Yep.
Right. Yeah. So it's kind of, but it's more like there is some maintenance in a lot of the enlisted sailors. That's kind of their primary responsibility is to be able to do like the maintenance at sea, and that's what their training is in, and that's kind of their main job. Yeah.
So and then on the again with sensitivity in mind, like the cryptographic type stuff on board though, is that like, so again my movie thing is like someone tears open a little envelope and they have the code and they type it in. Not so much, I'm guessing.
So that was in Hunt for Red October. They showed basically what that's called is 2-person control. Okay. So I was never at sea on a ballistic sub, but and that's where they do 2-person control for the authentication codes to start World War III. And so none of the things that I did required that 2-person control. What that means basically is 2 people physically have to be hands on something.
Yeah,
like
right.
You cannot
turning the key at the same time, kind of whatever. Right.
Yeah, like so if there's a message, like 2 people physically have to carry the message at the same time. Like you have to do this really awkward. Okay. So this again, it's like it sounds right. So it sounds all serious. So like, okay, this is the like nuclear launch codes, and this is a very serious thing. 2 people are holding it, but when you have 2 people on a submarine trying to awkwardly walk down, so that they both
not a very long or wide hallway, right? Like
right. So these are kind of like some of these kind of like just kind of funny situations I always kind of picked up on.
Yeah, I mean, again, another. I mean, when I picture you on the sub right now, I'm pretty much picturing like Kelsey Grammer down Periscope style, like. Oh,
yeah, that was a good movie. I did like Down Periscope. Yeah.
Yeah.
I don't know how I lasted that long. I mean, it was quite painful for the first couple of years, and then I kind of like got into a groove, and it wasn't so bad. But I mean, there's a lot of funny times, there's a lot of like fun things, but a lot of it is just working very long hours is very painful. You're away from your family. So that's all the painful stuff, which I tend to repress.
Right. The drudgery piece, right? I mean, it's yeah, that sucks. So again, to go back to the cryptography piece though, so the kind of practical cryptography, like hands-on everyday type stuff, that was more just encrypting messages that go back to shore kind of stuff, or going up to satellites or whatever it is.
Yeah, so it's just kind of like, So it, like basically anytime you have the option to encrypt a transmission medium, it would, you try to do that. So it's not, as a submarine operator, you never really got into like what was doing or, how'd this work. It was mainly just like, oh, I have to, make sure this green light is on and I have to use this equipment to make this light green.
Got it. Okay. Yeah. Yep. I got it. Okay. Well, how about you pepper us with another story here?
Oh, okay. All right.
So since you have a list, I mean, come on.
I did have a list. Yeah. So I had to run them. I don't know if I said it, but I had to run them by through my wife.
Run them by the wife.
Sure. Yeah. Well, so like, on the like joke telling thing. So like, a lot of times it's like actually quite boring on a sub. Like it's you are even on the periscope.
I imagine. Yeah.
Yeah. So, there's a couple things you do to kind of keep yourself entertained. And, I'd like to tinker and, I'm in security. So I'd kind of like, try to hack things and stuff. So there was this guy and we were doing this exercise and, what you're supposed to do in this exercise, you basically have to keep this log of everything you're seeing and you kind of are typing it in Microsoft Word and everything.
Oh, yeah.
And so we're doing this exercise and this junior officer is like, he's got to type all this stuff in. Well, Microsoft Word has this nice feature where you can do autocorrect.
Yes, that's right.
Right. And so it's, if you constantly misspell it'll fix it for you. But if you can add to the autocorrect dictionary. And in this exercise, we were like seeing fishing boats and pretending, they were like warships and stuff. And so what I did is I changed like fishing boat to like a kind of warship in the exercise that would be like a much bigger deal.
Oh my God.
This poor guy, he's like, typing these in and he's like, oh, we saw a fishing boat, saw this fishing boat. And then it gets autocorrected and it's like, saw this destroyer. And it sounds... If we had really seen them in the exercise, it would have been like a much bigger deal, but it just casually sounds like, oh yeah, we saw a couple of
whatever.
Yeah, I was like, whatever. So
enemy worship.
Yeah. So the executive officer, who's the second command, finds this one and he just starts like reaming into this guy. He's like, what are you writing? Why are you making this stuff up? And he's like, sir, I don't know what's going on. I thought I'm writing fishing vessel. And he's like, you did not write fishing vessel. It clearly says, destroyer. I'm like, why are you lying to me? And so he got it pretty bad. But yeah.
Oh man. Yep. That's great.
But yeah. So after like all the submarine escapades, then I went to work. So this is kind of how I got more into electronics. Is I went to work for a defense contractor as an embedded software engineer.
Okay. Yeah.
Yeah.
And you mentioned little black boxes and stuff like that too.
Yeah.
Yeah. Okay.
Yeah.
It might be coming up against the not allowed to talk about what's inside of it, but I'd be curious about the more generally about like working in embedded software in what I presume is a kind of slower environment, just because of approvals and long timelines and stuff like that. So what was that like?
Yeah, it's very much like the classic waterfall style engineering development, and it's because these are government projects. They have very large budgets and very large timelines, and they spend months doing systems engineering, which is basically coming up with requirements and putting them in spreadsheets for a very long time, and then mapping all these requirements to like software requirements and hardware requirements and mechanical requirements, and then you start doing each of these, and it's like it all looks very good on paper because you have nice Gantt charts and
of course the 4 weeks for design, 4 weeks for building, 4 weeks for testing, you're done.
Yeah, so it's very much process oriented. This kind of thing. And so it was, you get to work. I got to work on at the time I think it was some kind of super cool stuff. It is I've realized though that like sometimes it's nice, it's good for engineering to have constraints. And especially in time and money. So it's a much different challenge. Right. Yeah. When it's
like a design document or a system engineering document is a constraint. It's just not the one you're talking about, right?
Yeah, and so it's like, when you're doing things that are like I would imagine like safe, especially safety or for the military. I mean, there's just so many extra requirements where it's like, well, whereas a consumer product, it's like, well, we could do this thing, we could this be this much more efficient, or this much maybe doesn't, there's not as much failures. Where you go that extra 20% and spend a lot of extra effort to over engineer basically to prevent.
It asymptotically approaches this ideal thing that like
exactly
you can spend 4 years doing it, but why should you? Because you have competitors, and in a marketplace you have competitors. Whereas in a government thing, it's usually you've already won the contract, so why not?
Yes, yeah. And I mean, it is for. I mean, I tend to be a bit cynical, but for the reason is like some of these things are obviously very national security or safety. So I mean, there's reasons. Yeah.
Okay.
Yeah.
I mean, what kind of again, stop me if you're not allowed to talk about certain things here, but like what kind of language were you programming in? And
so mainly was C, C and C++. So I had, this was back, so like I said, I was mainly a software computer science undergrad, and then I started doing this, and then it was mainly in C, C++. And this was actually, I had been on the sub for 5 years, so I really hadn't programmed
right
in like 5 years, and then I get the job as embedded programmer. And so I think a lot of my military experience helped out because I was like basically working on some of the products that I had used.
Oh, that's kind of cool. Yeah.
Yeah. So that was kind of neat. So, but like at the beginning there was like, oh yeah, I remember how to do this.
Right.
Oh, I don't. Yeah.
Volatile.
Yeah. Like, oh yeah. So it was a kind of a steep curve there in the beginning, but I think I picked up pretty quick. And then, embedded C, and then I went back to grad school, at Drexel University, and it kind of focused on security. So again, it was a computer science degree focused on security and anonymity, kind of like things like Tor, kind of like studying these kind of, yeah.
Could you explain what Tor is for people that don't know?
Yeah, so Tor is basically an overlay network system, and so it runs on top of the internet. So it's a network on a network. So that's what overlay means. And its main purpose is to provide anonymity, and it originally did this mainly focused on your IP address. And so Tor got started actually as a defense project, and so the defense aspect of it is, well, you can imagine there's some military analysts, and they are in the military, and they're basically Googling what other countries are doing. And so if you do this on the normal internet connection, like your source IP address is going to show up in some log somewhere. And if someone does the reverse lookup, they say, oh, this is interesting. There's a us.mil person doing the search. Isn't that interesting? So that I think the original purpose was like, well, maybe that's not a great idea. And so there's these two, the main researchers, Roger Dingledine and Nick Mathewson, kind of proposed this protocol basically of trying to hide your IP address by going through a series of hops called nodes through the Tor network. And so that when you have three levels, I think 3 levels of encryption, it's been a while. Basically, you encrypt packets, you send it to the first node. That first node strips it off like an onion. So that's kind of what their logo is, this onion.
Right, onion Tor.
Strips it off. Yeah, and then it sends it to the next node, it strips off the next layer, sends it to the third node, and then that third node sends it to, which is called an exit node, sends it to the final destination. So that destination server, when it looks up your IP address, they get the IP address of the exit node, not your IP.
Oh, wow. Okay.
And so this is, solve the immediate problem. But one of the things they had realized that in order, and this is a problem in kind of any anonymity. So I did some research into anonymity systems, is that you can't hide by yourself, right? Like you can't go into a crowd of one and be anonymous.
Oh, right.
You need to have a big crowd in order to hide in. And so part of the design of Tor is that they want to get a large number of nodes. And so there's this giant pool of nodes that can help mix and the traffic as it goes through.
Got it. Okay.
And so now it's used. Yeah. So now I don't know if it's being used for the military or how long that lasted, but a lot of the main application is like for countries where there's lots of internet censorship. So you can get, and there's, I think one example was a few years ago, like in Turkey, they tried to block Twitter, but if you use Tor, you can get to Twitter. So things like this.
Yeah, that's good. That's a practical example. Yep.
Yeah.
Cool. Okay. And so like when you went back to grad school, it's like, first off, I've never heard of I guess I should assume there are, but I didn't know there were security-based programs. So what was that like?
Yeah, so it wasn't really. I mean, it was a generic computer science. I think now there is. Now there's starting to be like cybersecurity stuff. So I mainly went for computer science, but I just kind of focused on security classes. So I had this professor. Her name is Rachel Greenstadt, who is fabulous professor, and she taught mainly the secure privacy, and she ran the privacy and security lab at Drexel. And I basically took every class that she offered. And so, one of the classes was like software security, and you learn how to do basically how to do Stack Overflow and all these kind of buffer exploits. So you do those as assignments. Those were a lot of fun. And then she has a lot of classes. She focuses on anonymity stuff. So then there was like four classes of like security related stuff out of the computer science degree there. Yeah.
Okay, that's cool. That's cool.
Yeah.
So then, so like, I guess what I'm always getting at with security. So first off, I'm always curious how there's so much money in the security industry. I get it from a practical perspective, I think now, but it still never stops boggling my mind.
Yeah. Yeah. Well, I mean, there's like a few. There's a few levels there. I mean, so one is like, as a business owner being in there, and then kind of seeing where how are some of our clients like where, and then I think a lot of it is. So not everybody. I mean. Not everyone has this kind of, so there's not a lot of people in security, like compared to a normal, like software engineers, right? So like if you're a software, especially with software, there's, comparatively a lot of software engineers to software engineers who know security. There's fewer hardware, electrical engineers, fewer of those who also do security. So it's just this subset of, like a pool who can do this kind of thing, I think.
Yep. Okay. So then from a practical perspective, as like an embedded software engineer now, an embedded software security engineer, like what does that end up meaning at the end of the day?
Yeah. So, what it is, I think a lot is, so then there's also different hats there's like the hat terms overload, but let's just say different sides. So, right, if you're a developer and if you're working for like a defense contract where there's certain where there is this kind of nation state like level attack threat, there's a lot. It comes down to basically writing software that is not filled with vulnerabilities, and so there's a lot of emphasis put on making sure like the code is written in a certain way. There's lots of code reviews. There's lots of standards. It's a lot of time is spent on code quality, I would say.
Got it.
Whereas like a consumer, if you were like writing some IoT thing and you're like, oh, I got my code to work, pass my unit tests, and it functionally could do. So I guess a lot of security is negative testing also, right? So if you do a test, whether it's software or hardware, you're like, I need these things to be in this spec. So if I'm making the circuit has to have a response of this frequency, right? And you can do that, and you could, say it, pass this test, therefore pass the specification. A lot of security is trying to get it to do things it was not designed to do. So, and these are just like negative tests. So like, can you abuse this circuit or this software in a way that wasn't designed to get a failure of the system that you can use to exploit? So
gaining access to the cryptographic keys or
yes,
getting root access, that kind of thing, if it's a higher level system, that kind of thing.
Exactly. And then even, for hardware, it's a similar kind of thing. It's like, can I get this system to get it outside of its operating conditions, either the voltage or current, and does it, so I gave this talk last year at DEF CON where I did voltage glitching attacks on Bitcoin hardware wallet, the Trezor. And so what I was using Colin's chip whisperer device, and we were trying, essentially the idea with the voltage glitching is you try to get the microcontroller to operate outside of its, there's that nice curve in the data sheet that says, keep everything in this nice parameters, and we guarantee, everything will be fine. And so, security again is getting things operate outside of those parameters. So voltage.
So what were you trying to? So you were basically tugging on the voltage rails of the wallet, right? And then what were you hoping to do with that?
So you basically try to get some fault to be introduced where the fault is some sort of memory corruption. And so the way this can be, the way this manifests is, say you were about to read from flash, and so maybe the flash bytes that it reads aren't the same as what's actually in flash, right? So as it's reading from flash and it's pulling the data out, it no longer reads the right value. Or it could be memory that's on the stack. So if you're executing a loop and the loop is supposed to execute 100 times, but you apply a voltage glitch, maybe it only executes 99 times. And is this a problem or not? Well, maybe yes, maybe no. If you're doing if you're looping for a security reason and you're able to get the loop to misbehave in a way that the developer didn't intend, you could. So what we were specifically trying to do is actually this loop attack example. So the Trezor has this feature where if you enter the pin wrong so many times, it just goes into a busy spin loop. So it's just while it uses a uint32 and it just loops in the processors in a hard loop. And so the idea that we were trying to look into, which ultimately didn't work, but we were trying to apply voltage glitching while it was in the loop to get it to bust out of the loop. And if you could break the loop, then you could have more free tries, essentially, to guess the pin.
Oh, I see. And that would allow you to then start doing like brute force attacks and stuff like that?
Exactly.
I see.
So that ultimately was not successful. We did find some other things. So for example, the Trezor, we did try to do clock glitching as well. So voltage glitching is you do this by essentially shorting the power supply. Clock glitching is then inserting, trying to make the like messing with the waveform to the clock, and such that the hope is you get the processor, because of the pipelining and all this, you get it to essentially skip an instruction. And so we tried it with clock glitching. It wasn't effective, but we did find that they did not. There's this microcontroller which was a STM32F2 had a basically bit called clock system security, and if they turned it on, the microcontroller could detect if the clock failed, and then could do other things. So at the end of the day, that's one of the changes that they did incorporate, is they turned on this clock sensor.
Got it.
So
okay.
Yeah.
And so you guys weren't trying to do it to actually get anything out of it. You were just doing it to get the research of it and understand where there might be vulnerabilities.
Yeah, I think we do. We do engagements where we're doing penetration testing or audit of someone's product. This, I think I was just curious on. I have some of my clients are in the like cryptocurrency space. I've kind of like dabbled in there too.
Got it.
And so, was like, well, hey, people are making these like, storing lots of money on an STM32, right? Is essentially.
Yeah, that's a little crazy.
Yeah. And so like, well, maybe there's, maybe, and usually a lot of security research is like just looking under the rug, which no one had looked before. So it's like, like there's, so I'm, next month I'm giving a talk with Dmitry Nidos and Thomas Roth at CCC in Germany. And we're kind of continuing some of these wallet hardware attacks. And Thomas gave a talk last year about some industrial Internet of Things, and he basically got a bunch on eBay, and then just found, he like out of like 5 or like 6 of them, and basically all of them had like some decent security problem. And I just don't, maybe no one has like decided to look at it. I mean, so some of it is, if you look under the rug, you're going to find some bugs.
Right. So, well, tell us more about that talk. I mean, how much are you willing to talk about that talk?
Yeah, so I can talk about it a little bit. We want people to kind of, I think they're going to be streaming it. I think CCC, it's my first time going to CCC, so I think they stream it.
They definitely at least put them up after the fact. So
yes, okay, cool. So so like I said, it's Dimitri, Thomas, and I, and we're kind of looking a little more broadly at some of the Bitcoin, cryptocurrency hardware wallets, and just a quick background of what those are. Is that essentially, if you do anything with cryptocurrency, it all comes down to public-private key pairs. You have to store your private key somewhere, and so the thought is, well, if you did it on your phone or you did it on your desktop, like the software is obviously insecure, so let's just put it into quote unquote hardware, which is just software running on a microcontroller. And right?
When you say private key, it's literally like a 2048 type of character string or something bigger.
So Bitcoin uses elliptical curve cryptography, and so there's basically if I'm thinking of this like kind of diagram, and so you have symmetric cryptography, which is both parties have to have the same key in order to communicate. Asymmetric cryptography generally is there's a public-private aspect of it. So public-private, asymmetric are sometimes used interchangeably. So with Bitcoin, they use so then inside of asymmetric cryptography, there's different schemes that you can do. RSA is kind of the classic one. that is like, you'll see like RSA 2048 bit key or a 4096 bit key. Elliptical curve cryptography has the benefit of having much smaller key sizes for roughly the same equivalent security for the key. Bitcoin uses elliptical key cryptography.
Okay.
Then more specifically, they use it's the curve like SECP 256 K1. So then there's different elliptical curves that can be used in different elliptical cryptography. And then, but basically it comes down, there's a private key. It's 256 bits long. That key can sign operations. So again, with asymmetric cryptography, if you sign something, you keep the private key, but anyone who has the public key can verify it. So this is essentially how you transfer money in Bitcoin. And so you have to keep.
So does that mean that like your key plugs in though, and then it like that's what when it's signing, it's saying like, okay, push your bits through this engine I have a private key stored in here, and then I'll push some bits out that are encrypted or whatever.
Exactly. So so signed, right? So the kind of whole idea with the hardware wallet is that the private key stays in the memory of the microcontroller or secure element, and it never leaves into the host computer. And so you have to send over the transaction. You say, hey, hardware wallet, please sign this. Please authorize, sending of funds from A to B. The hardware wallet, generally, they all have some sort of display where they say, do you want to send all this money to Chris? And you have to click yes or no.
Yeah, of course you do.
And then you say yes or no, and then the response comes back to the host, and then the host uploads it to essentially the Bitcoin network, and so it can do all that decentralized kind of stuff. But it all comes down to, at the lowest level, it is just an elliptical curve digital signature algorithm, or ECDSA, and it's just the sign operation that happens in the microcontroller or whatever hardware.
So the ability to either extract that key or mess with that in between stage and insert some other key, you could basically pretend you're someone else and pretend to take their money, that kind of thing.
Exactly. So if you can get to, if you either can get the hardware wallet and extract it, you would be able to transfer their funds. If you can observe, maybe there's some parameters. So these are called side channel attacks. So normal operation of the device, but say it leaks information. It could leak power information. It could leak other kind of emissions. And say you monitor those, then you could potentially extract the key. Or there's other. I mean, also the wrench attack works, where you would just go and say, so there's the classic.
Give me your key, or also hit you with the wrench.
Yeah.
Okay.
Yeah. So there's always so you always have to worry about
the human element, right?
Yes. Yeah. Yeah. So we Dimitri's background is looking into, he had a PhD in some silicon attacks. He teaches a class that goes into a lot of glitching stuff. So
also past guest of the show twice. So
yeah. So I think he saw my talk, and then we started chatting as to kind of how we got involved. So there's some glitching stuff. Thomas is a very impressive reverse engineer, among other skills, and so there's some some of that. And then I'm kind of looking at some of the glitching stuff again, like I did last year, and then I'm kind of looking at hardware implants, which I gave that talk a few years ago to DEF CON, kind of dusting off. Because the hardware implants have been in the news.
They have, yeah. Well, why don't you give a recap of that? I mentioned it briefly when Joe Fitz and Joe Grand were here in town, and then I mentioned that briefly, but I really didn't do a good job explaining what it is. So could you explain that whole situation?
Yeah, to the extent that I followed it. I mean, I think I remember reading this and I said, this is just crazy. This
is the Bloomberg story?
Yes, this is the Bloomberg story about super micro computers. I think so. They specifically said there were super micro servers that had, essentially their claim was there was a backdoor. I think they allegedly said it was a Chinese backdoor. And they had, infiltrated, Apple, Amazon, Google cloud infrastructures with this backdoor into their server hardware, which I think was the claim. And so, which is, if that's true, that is certainly newsworthy, right?
Yeah, right.
Yeah. And so, but as people started scratching the surface, and I think both Joe Fitz and Joe Grand were interviewed for this, but I don't think they knew there was all these weird details that were coming out, but. I think when I eventually looked at it, there's this picture, and it's on the cover of Bloomberg, and there's this little chip that's tinier than the pencil point, and it's on the cover, and they're like, "This is the hardware implant. We found it," and someone did like the reverse image search and figured out what that chip was, and it was like an RF. I'm blanking on the name. It basically it's like not really a multiplexer, but could like pass RF into two different signals.
Oh yeah, like a splitter or something. Yep.
Yeah, and so it was like this is not. They were claiming this is like some nano computer. This is like this crazy technology, and I'm like, this is like you use to detect if you're in an RF field or something. Like this is not the hardware input. And then so that details started to get sketchier and sketchier. Like this doesn't, like things aren't adding up. And then I think both the Joes kind of talked about, because they were interviewed in there, and then they kind of came out later and they're like, if you were doing a hardware implant, you wouldn't do it this way. I mean, there's just so many easier ways. Like you would just need to be able to reflash like some of the components on there. Like if you just grab the server, and these servers have a SPI flash on them to keep some of the bootloader and all these things. Like you can just pretty easily just modify the modify that SPI flash code. There's just all these other things that are way cheaper to do than
developing
a nano computer and somehow make it look like an RF splitter.
Right.
So I've that so that occupied like the news, I think, for a few weeks there. But when I had so my first DEF CON talk was when this NSA catalog was released. They had actual hardware implants that allegedly had come from the NSA, and this is how they would like get into.
And this is like the one where you have you do backscatter on like a VGA cable or something like that.
Yeah, so that Michael Osmond did that one, and he used a hack RF and basically did an RF retroreflector. And then so he illuminated with basically a radar to this transistor and was able to read out some of the serial data on whatever bus he was targeting. The one that I did was a device called the Chuck Wagon, and there was like some talk in there about like there was some implant that was over I2C, and then they had some GSM modem capability, right? So they clearly, it sounded like, well, over a GSM network they could talk to this implant, which would then inject commands over I2C. And I was like, oh, that was that's interesting. Like, how would you do that? And so I was like, start thinking about like what are I2C buses on a normal like x86 server. Mm-hmm. And I was like, well, this is interesting. Like every x86 server, has this VGA port that goes out. And what do you know? VGA has EDID to get the monitor resolution, and that's I2C. And it also has power, right? So there's like, and so what I built,
everything you need, right.
Yeah. So right there, and you hear in the government, like, when I was there, they were like putting epoxy in USB ports, and it was like, oh, USB is evil, right? And so it's like, everyone's like USB, I gotta lock that down, right? But like every desktop I know has some display port, otherwise it wouldn't be very useful. And then servers have them, so you could get the crash cart. So I took a BeagleBone, and I had made with SparkFun this thing called the Crypto Cape, and I had put some like security chips on there. And it had an Atmega 328p, and it had, this is basically just like a security dev board. And I put it on the BeagleBone, and I put a VGA adapter to it, and then I put a GSM modem on there. And so I plugged it, so the demo that I gave is I plugged it into my laptop, and I had to assume basically you had, somehow gotten access, a software exploit where you could talk to the I2C channel. But basically at DEF CON, I was able to text my hardware implant, and then it received the GSM text, and then inserted a command over I2C to the laptop, and then ran something. Wow. Yeah. So, okay. So I kind of done these like hardware implant stuff, and then there's the whole NSA playset, which I think Dean Pierce came up with that name, and then there was a bunch of people who had kind of taken some other projects. But so hardware implants, but they're generally like, so they do, they are a real thing, and they're generally not. I mean, I think the conclusion of this NSA playset stuff is that they're not like, you don't need $1 billion to make one of these devices. They're able to be made. And they bypass.
Well, you do have, maybe if you want to do that, but you have to do it through the defense contractor, hierarchy
exactly,
like you're talking about, right?
Right. Yeah. So I've never heard back. I've never gotten any feedback, from the government if like, they took my design ideas from my BeagleBone and made a better hardware implant. But
right. Who knows?
But yeah. But
so, what about like generally working with the government? I mean, like, so that's something that I think, people listening probably are doing. And obviously, you've done that in the military as a military contractor and now as a security consultant, I assume, to people that are working with the government or directly to the government. Like, what is that interaction? And I'm sorry, I should be much more broad about this. The U.S. government, I don't assume other governments. So what is that process like in general? I mean,
yeah. So I as now a civilian with no connections, I do not have any government contracts. We don't do any government. And a part of that reason is, so you'd have to maintain a security clearance. And I have a pretty epic story about a security clearance, which is definitely better told. Yeah, okay. I know that one.
Take Josh out for a beer and then he'll tell you that story.
That one is pretty good. But also my wife was born in Iraq. And so when we go to war with a country that you marry someone there, it is not easy to get a security clearance. And so I am not. I am very much done with the security clearance process.
Right.
So I don't have any
happily a private citizen and no chances, no chance or interest in going back.
Okay. We're done with that. So
got it.
So I've never bid on a contract or anything like that, but I've seen it kind of as a contractor. And, being in the military, and it's from what I understand, it's if you're actually bidding on these contracts, it's some of them can be quite a lot of money and they don't actually pay, they don't pay net 15. It's more like net 1 year, so it's if you're a small company, and you take on a lot of risk. We were talking
about that last week, I think, too, about net terms and stuff like that. And how arbitrage that. But the government doesn't care,
Yeah, right. So I kind of vaguely know of some small companies that do defense contracts, and if you're in there and you know how that works, I get the sense it's very it's a decent business, financially. But yeah, there's a lot of headache, which there's a lot of paperwork. So I went from the military, which is a lot of paperwork, to working for defense contractor, which is less paperwork, and now I'm quite happy to do less paperwork. So I'm de-escalating my paperwork
now.
Yeah, right.
That's good. That's good. So, what are you excited about in the security industry or the hardware industry these days? I mean, what does it look like from your vantage point as a security researcher?
Yeah. So, I think it's still, people are getting, the ocean is the level of the sea is rising a little bit, with how some of the hardware, even consumer hardware security, it's not, there's less, people are starting to get the hint, I think, where hey, it's not good to leave maybe JTAG open or serial ports open and so I think some of that slowly getting there. I think a lot of that is to some of the silicon vendors are starting to make microcontrollers with more advanced security features. So certainly that helps. If you're sourcing components, now there's more most vendors I think at least have a security chip. There are obviously ranges of the kind of quality there, but there's at least more options. And so the silicon vendors are kind of making people aware, and that's trickling down to the field application engineers, and so people are kind of hearing about this more, which I think is kind of bringing it up. But on also the attacks get more sophisticated and the attacks get cheaper, so it's always this back and forth cat and mouse. So it's yeah.
Well, I think about the people listening here, right? They kind of they span the run the gamut of people doing stuff in their basement as a hobbyist project up to people that are actually doing hundreds of thousands of units, right? Some people listening are doing that stuff. I assume the ones on the high end are more likely to be thinking about security, hiring security consultants, being asked about security, or actually are at risk of being targeted. But what are some best practices kind of even sliding back down into the hobbyist level, right? So I assume that if you're learning, maybe you don't have to do it right away, if you're just getting started and embedded, but as people start building products, what should people be thinking about, or best practices they should be doing when they're designing new circuit boards and that have micros on them?
Yeah, so a lot of it is isolation. So one way to think about security is in kind of on a personal or hobbyist level is isolation. So if you make your Wi-Fi garage. So I should step back and say so there's this term called threat modeling, which is a security industry term, and really it's kind of just doing a risk assessment. And so this sounds like a very security kind of focused thing, but basically every engineer does this, right? So if you're making, trying to make your Wi-Fi garage opener, right? You would say, well, okay, I can do it this way. I could use this new part, and maybe I don't know how to do this, or maybe this is more expensive. So you're already doing this kind of trade-off analysis already.
Right, like what can go wrong?
Exactly.
What should I thinking about, right? And security is one of the other inputs.
Yeah, and so doing a threat model is just the kind of like putting a name to the kind of security-minded thinking of it, and a lot of it is thinking like, well, how is this going to fail in unexpected ways? Which kind of sounds like an oxymoron. Like, how do you know when it's, how do you know it's going to be this unexpected
right.
thing?
You don't know what you don't know kind of thing, right? Yeah.
Right. But if you took the like, well, okay, I'm going to replace my garage door opener, right? And I want to make this like a LoRa, right? So I get a nice range on my garage door opener. I can open it very far and all this stuff. And so if you start thinking about it, you're like, okay, well, so I can do this. So you kind of make the thing first and like, okay, cool, it works. I can do it. And then the next step is basically like, well, if I can do it, like who else can do it? Can somebody else open the garage door? And then, so like to think about that question, you're like, well, okay, well, how would someone else open my garage door? Like, so if I can clearly make the transmitter and I bought the part off DigiKey, if someone can clearly buy them. So what do they need to know? I mean, they need to know that it's LoRa, so like, okay, so they find a LoRa transmitter. And then, what is the thing that makes it like this access control? So how do you talk to your receiver? Right. Is it just
who's in charge frequency here, right?
Yeah, exactly. Yeah. And so this kind of process, so this is the like threat modeling process is the kind of security name for it. But if you, it is not outside the realm of any engineer to do this, because I think basically every engineer, it's just that there's the practice and the mindset is something that you just kind of have to purposely think about versus like,
right.
Yeah. So for that, yeah.
I was just gonna say, I think that like, so I did a LoRa project recently, and I basically didn't think about some of that stuff too. Or I was like, oh well, it's not that big a deal if people know this stuff, or it's not that big of a concern right now. But then it, I when I think about projects, you say that, and then the project moves on, and you forget about it, and then it's like, so if you're not thinking about it up front, it doesn't ever get baked in later on.
Yeah, and so some of this is just formalizing it. So like, so based there, you have thought about it, right? So it's like, but so if you took it, I'm sure you thought about, well, the voltage, from the battery has to be this and this, right? And that's probably written down somewhere, some spec, and there's like, people can go look up and say, hey, what's the battery voltage of this? Oh, well, because it says in this design document, if it had matured to this level, right? There's some document that'll say battery has to be between this. So security engineering is kind of just like also formalizing that. So if it could very well be that this is not a big deal, because of the risks involved or whatever. But the fact that that's written down is like, well, we assess that the risk of like, something, someone inadvertently doing this or this is low because of the following reasons. And, you put that down in a document that is, in some sort of security document. And then if the project does changes where they're like, hey, cool, wouldn't it be great to use this Wi-Fi, this LoRa based opener? Why don't we put this on like all this industrial control systems and we'll just open all these valves, right? Like, cause it clearly works, right? Let's just do that. And so people were like, okay, yeah, the voltage works. This is great. All the specs are great. Oh, and then there's that security piece. They're like, oh yeah, we deem this not to be a risk because it was meant for like, some like prototype thing. And then that hopefully is the trigger, like any other requirement spec that, and I'm being
to think about it and be like, what is our actual risk here? Yeah. Right.
Yeah. Now I don't know to be like, that is my like, I would very much like to think that, there's this security engineer kind of process on all these products, but I unfortunately don't know many like companies that have that do that. I mean, some of the big ones, obviously the big ones do.
Sure. They probably have a team though too, right? They've already responded to other things, so they get called. They've had a security problem at some point. They retain a team, and then they're like, we should probably call these people the next time we build a thing.
Right. So yeah. I mean, it's like so there is this, it is like any other discipline of engineering. There is, there's lots of decent books and there's lots of mindsets and there's ways you can get into it. But it's if you looked at it from a like QA testing, like a traditional engineering process that didn't really have a security focus, it's a lot of just negative like you give this product, you're like, hey, I'm all done, passed all the positive QA tests. You give it to somebody like, hey, try to break this thing in a way that, we didn't intend. And then it's like, oh, turns out, like I can always make this valve, open, but I can make the indicator stay closed. So this is one of Joe Fitzpatrick's examples.
Okay.
But yeah. And then, that could be a problem if you're cycling an industrial control valve, but it's reporting that its status is not changed. Right. So this is
that's bad. Yep.
Yeah. Right.
I've worked in facilities, and that's real bad. Yeah.
Yeah. So yeah.
Okay.
So yeah, I think we tried to help. So now. Yeah, so now there's like 4 of us, and so now started off just by myself, working on the Crypto Cape and doing conferences, and then now have slowly got more work, and now there's 4 of us doing this. So we generally try to like help. I mean, what I really like doing is being the kind of security engineer working with an engineering team. So if there's a team,
so you're called in because they're not retaining an entire team. You're more of a consultant that comes in and plays that role you kind of described.
Right. So like for new product design, they're like, hey, we want to make this thing, and I'm like, I really like, I like breaking things. That's like part of the fun of security is attacking and breaking. I also like the kind of like building engineer in me really likes building systems. And so I really like working as the security engineer on an engineering team where there's a hardware guy, there's a firmware guy, a mechanical person. I really like, and I think that's, so some of our clients are really kind of more longer term engagements where they're doing kind of this development. And then, occasionally we'll do the, like, they've made the product, let's do the assessment, see if there's any security problems. But I really like getting in there early in the design phase and helping them pick the components, especially on the hardware side, kind of like if you don't get some of the hardware security stuff right, there's only so much software can do.
Right, exactly. Yeah. You've written firmware for a part that doesn't have like a crypto core in it, and you're like, okay, well, I guess we could do this all in software or in firmware, but that's not the best place to do it. So,
right, and so if you're like, well, that may. So again, a lot of security is like, is that a problem? If no one can ever get hands on to the device because there's a Marine station 24/7 with an M4, and every time you try to touch the device, he butts you with a rifle. Physical access is not necessarily a problem, right? But so then maybe you make some different design choices. But if this is like a Bitcoin hardware wallet and people have it in their hands and they can lose it or they can be stolen, there's some different design requirements there.
Do you know people that carry that? I don't. I've avoided all the cryptocurrency stuff, but do you know people that carry those around?
Well, yeah. So Dimitri, so one of Dimitri's like funny things to do is he'll go to conferences. He'll go to a cryptocurrency conference, and he'll be talking to someone who's like, do crypto, yeah. And he's like, hey, did you leave your wallet in your hotel room? Right. And you'll just watch their face. He just watches their face go white, right? Because they realize like who they're talking to. And they're like, oh, okay. Right. So it's like, so this is some of the things that we're kind of probing at. Yeah.
So like just kind of cultural things as the culture builds up, even though it's a ridiculous culture. Sorry, I made a little bit of a judgment there myself.
No,
but,
so I am fascinated. It is kind of intriguing. I guess I'm very intrigued by cryptocurrency. So like I said, I had this background in like when crypto actually used to stand for cryptography. I had a background in that. And so I'm interested in cryptography.
Right.
Bitcoin came out and I was like, well, this is like kind of an interesting, so there is an actual computer science problem that it was solving. And I was like, oh, this is interesting. I kind of was, and then I was into Tor and some of these kind of decentralized systems. So I've been interested in the technology aspect, but then as it kind of like blew up, there's just this whole other world around it, which is interesting for more, like people watching and
the culture, the cultural stuff
which is
that develops.
Yeah, and so that it's very intriguing.
I think it's like any technology thing, though, right? Like the technology is interesting in the beginning, and then it gets used for something, right?
Yeah.
So you could say the VHS Betamax kind of thing, right? So like,
right.
Tape recorders are very interesting machines. However, the money was not in the guts of the machine or even making the machines. It was in the content that went on the tapes and the
right.
sometimes loop content that really drove the VHS right. versus Betamax stuff, right?
right. Yeah. So it like I have clients who work in there. I mean, I have done these talks, everything. I mean, and so there is a part of me who's like intrigued by this. But yeah, like I've gone. There was like Wyoming. So here's an example. So like I was at the Wyoming. Wyoming had a blockchain hackathon. And so I live in Colorado and Fort Collins. It's not too far from Laramie, Wyoming, where they have this thing.
It's not that close, though.
Oh yeah, okay. I mean it's a few drive, but like I mean it's the next state over. And Wyoming kind of has this like cool like Western kind of feel to it. So like I always kind of go to Wyoming. The wife doesn't like going so much because she complains there's not much to do up there, but it's fun. So I go to this blockchain hackathon, and Wyoming's trying to pass all these laws and trying to be this advocate for blockchain companies. And so they have this example. So, they're all, they had lots of sponsors. And one of the things that they were talking about was beef chain, right? So Wyoming is Wyoming. And you're like, so part of this, so a lot of this is, it's like kind of like what I was talking about in the military, like being in this thing and kind of being able to like step back and then just realize some of the ridiculous things that are going on,
and then I can't help but to laugh and mess with
it. Right. And so like, so I'm going to try to say beef chain without cracking up. But so they have beef chain, and so so there is a hint of an actual problem here. And so what so they had the problem of that they've got this cattle, and the Wyoming ranchers really want to make sure that the Wyoming cattle is appropriately like tracked as it goes through the process, right? So they added, they're like, hey, let's add RFID tags to the cattle. And so they have this RFID system. This is all, there's no blockchain yet, right? They just add RFID, they track the cattle as it goes through, and they had all these great, the meat processing. Again, I think I was the only person cracking up as this went in, as this like a very serious lecture was being given. But they had all these great euphemisms for like, how they actually hopefully if there's any listeners who are sensitive to animal stuff, but like how they actually slaughter the animals. And so it's the product, right? Like the product is being transformed, right? There's all these like great euphemisms, right?
Yeah.
So,
right.
So
to make it more like sanitized and like right. So I mean, it sounds almost.
Yes, right. I mean, the product is going through the process and it gets transformed, and all right. So it's basically going to the slaughterhouse. And so, so the cattle comes in. What the ranchers want to do is they want to tag the cattle when it goes through the processing facility. They want to make sure there's continuity of like, hey, this meat essentially came from this cattle, which was on this ranch, and this ranch, it was a grass-fed ranch and all this stuff. And so I mean, okay, so there's a legitimate, business concern here, and there's like,
right. And what they used to do is they would do branding, and then they did barcodes, and then they did RFID, and it's just technology has followed this same problem, but now they're applying a new technology to it.
Right. So, but like, I mean, the way I was reading into this talk is that like, okay, they wanted to do this thing, but like no one was really getting super excited about it. Cause like they would have to build this like database, they'd have to build like this traditional database and tracking, and like, okay, like you went from branding to RFID, but no one really got really excited about it. But I'm pretty sure what happened is what one day some guy was like, hey, if we put this thing on the blockchain, we might be able to raise money for this thing, right? And so they're like, right. So I can just imagine some meeting where they're like, oh yeah, well, let's do that, yeah, okay, because basically, then we
can find coders that want to work on it, right?
Right, yeah, like this is going to be like, so how do we do this? What do we call this thing? I'm like, okay, well, we got beef and we got blockchain. Well, let's call it beef chain, right? And so beef chain was born. And it's that same process that I just described. And then basically they're just, instead of putting it into a traditional database, they're putting it on the blockchain. But now it's sexy, and there's people who want to, develop, there's software programmers who want to work on it, and it gets attention, it gets newspaper articles. And I mean, so from a like marketing point of view, I mean, they're kind of onto something.
Sure. Yeah. I think it's totally a marketing term. It's just like IoT was 10 years ago, right? Even though there was actually people doing connected devices much before that, it's just the way that these hypes go. So
right, M to M, right, like machine to machine.
Yes, right, of course.
Which apparently just IoT, because you capitalize the first and end letter, and I think that what makes a successful acronym.
That's how you raise money. That's right.
That's it. So it is. I mean, there is a lot of I mean,
so
I don't
get to observe the ridiculousness from outside. You're saying. but
yes,
you also
and I
benefit a little bit.
Yes, yeah, and I think, I mean, even in security, I mean, it's not just, it is a little more. There's in blockchain stuff, but like, I pretty much in everything I did, like in the Navy and in Afghanistan. I don't know. Is it time for another story? Should I do another?
I think so. Yeah, I think maybe we should end on a couple stories and then cut it off. But
okay.
At this point, if people are listening past Beef Chain, they probably were staying for the stories.
Yeah, right. Yeah, that's true. Yeah. Okay. So let me look at my list here to see. Okay. So they
You got any Afghanistan stories?
Yeah. So Afghanistan. Okay. So the reason I was in Afghanistan is itself just odd. Like it's very much a Joseph Heller catch-22. Yeah, a submarine officer. So I was in the reserve. So I was in a civilian job, and then they recalled me. Right. So they're like, hey, you are of enough importance to national security in this thing that we have to pluck you from your civilian job, and you're going to go over and fight in the war. They're like, oh man, okay, well, oof. Okay, how long am I going to be there? Well, you're going to be there a year and a half. I was like, oh, that's a long time. And they're like, well, what am I going to do? And they're like, yeah, your orders say you're going to show up at this base. We don't actually know what you do. Like there's some number. So I didn't even know what I was going to do. And I'm like, oh, wow. Okay. So like I get the orders and I get mobilized and I go to, I start to do the training, which was we went somewhere in Georgia and we did like Army for Navy officers. And so like you do a whole bunch of shooting.
Okay, like like a basic boot camp kind of thingy, but basically learning how to do it on land.
Right. So basically, I think it's the idea that like if you happen to be, so I mean like basically the idea is the Navy and Air Force personnel go into the kind of like combat support role. So basically the desk jobs, so that the Army people, the Army personnel can actually go and do like the war fighting, right? And so this is, for whatever reason, I am convinced probably there's some like budget reason, like they couldn't get more Army personnel, and so someone was like, well, we'll just send Navy people. Yeah, right. And then we'll staff them, and then everything will work out great. And so I get sent over there, and then I'm in the training in Georgia, and they're like, oh, Lieutenant Datko, oh yeah, you're going to need an so typically just the officers get a pistol, which is the M9 Beretta. And so they're like, oh yeah, Datko, you need a M4. Which is the AR-15. You
still don't know what you're doing, and basically
I still don't know what I'm doing.
This big weapon now.
Yeah, but all of a sudden they're like, yeah, you need this M4, and it's like, I'm like, why everyone else just needs a pistol, why do I need two? And I'm like, they're like, oh yeah, because you're going to be going outside the wire, which means like you're going to be going outside the base and doing missions out in Afghanistan. And so I'm like a Navy submarine officer. I'm like, okay. I learned
something today.
Yeah, it was like, this is okay. So then so I did all of the shooting stuff and passed all that, and then I get so I still don't know what I'm doing. So I just get told like, show up in Afghanistan, go to this guy, meet him, and then he'll tell you what you're doing. I'm like, okay. So I go over there, Bagram Air Force Base, and I meet this person, and they're like, yeah, Lieutenant Datko, we don't actually have any record of why you're here. Like, do you know why you're here? I'm like, what are you talking about? I'm like, I'm like, I've got these orders. I had like the civilian life. Like I spent the last month like learning how to fire all these weapons. Like, what do you mean there's no record? And they're like,
I think I'm a spy now, actually.
Right. They're like, well, they're like, well, what's your background? Like, yeah, I do this, like I do like a program. I do like embedded software, like electronics. I'm like, okay, yeah. Like, okay, go talk to this guy. I'm like, okay. So I go talk to, like, I show up and I go to this building, right? I'm like, walk in. I'm like, I was told to check in here. I'm the new guy. And they're like, oh, okay. So I was working with this group called the Joint. So it was J Crew, which is an acronym within an acronym. So let me see if I can decompose all the acronyms. So it's Joint Counter IED, which is Improvised Explosive Device, Radio Electronic Warfare, or something. Basically, it's jammers. So you can imagine.
Okay, so you're out driving and you don't want to have like a remotely detonated thingy.
Exactly.
And so you say all of the energy in the spectrum so that we can drive through hopefully safely.
Yeah, right. And so they're like, oh, you seem to know something about electronics. Why don't you go work with these jammer guys? And so I was like, okay. So I go over there. But it was just like this situation. So I was in this old, we're on Bagram Air Force Base, and it was an old Russian building. because the Russians were there way before us. And then like none of the doors, like every like it was like 4 feet concrete. None of the doors like ever closed because they're all like bespoke. Someone just poured concrete, and it was on this base, but the base, like there was more civilians walking around than military, right? So like I would be on Bagram, I'd wake up, I'd go get coffee. At like there was a KFC. There was like, and I'm like, this is different
really
than my submarine experience. Like, I could get on the internet, and it was just odd. And then, occasionally there'd be a couple mortar attacks. I mean, so the base, so I was a submarine officer. There's a reason I picked submarines and not Marines, right? So like, I never wanted, no desire to go, so like people would come in and they're like, hey, Lieutenant Datko, you want to go on the convoy down to this FOB, which is a forward operating base? I'm like, no. They're like, oh, you can just ride on. You can just ride along. I'm like, I'm okay. Like, I don't need that excitement in my life. Right.
Right.
So,
right.
So it's just weird. And so like, there you get mortared, and occasionally mortars would land on a bunch of people and kill a bunch of people and stuff. But like, otherwise it was pretty safe.
Jesus.
I mean, on the base. Yeah. So, but like again, like I can't, like I'm just in that situation, and like I find this ridiculousness. So there was this, there was this guy, and he was this Air Force guy, and he, a very serious kind of person. He's like, like you would, most military people, he followed orders and stuff, and as you would expect most military people to do. So he's a very serious guy, and one night. Somehow they were doing construction like right next to where I worked, like, I don't know, 30 feet from like the barracks I was in. But they were doing construction or something. And so we had to be rerouted to walk around into this other area. And it was like poorly lit, and there was like gravel, and it was just kind of like a spooky area to walk back around. And so I had got the idea, like, oh man, when this guy walks back, I'm going to sneak up into him, right? I'm going to like scare him. Yeah. And so I, I'm like going to jump out and get him. And then I realized, like, actually, we're both wearing loaded pistols, right? Like,
that's exactly what I was thinking. Right? This is not safe.
So I had like waited for him to go by, and then I just like jumped out, like scared him, and I was like, oh, this could go bad, actually.
So bad.
But his face went completely pale. So that was funny. So then another one is like.
Josh,
waiting in line.
Do you still tempt death like this? Is this like you like oh look, there's a beef chain bull over there in that field. I'm gonna go wave a red flag in front of it.
Right. I think this is kind of how I got into security a little bit, because it's like, a lot of things is just probing things and like trying to do things that you're really not supposed to do. Like, why, well, who says I can't like open this thing?
Maybe I should unlock this thing. Maybe I should try and hack this thing, right?
Right. So a lot of it, I think, it just comes from being like curious and just like prodding. So like, there was another one. So like so you have to eat in these dining facilities. So they're called DFACs, where you eat, everyone goes to eat. And there was this sign, and I remember seeing the sign, and I was like, and then the sign said something like, no shirt, no shoes, no gun, no service. And I was like, oh man, I should take a picture of the sign, because they're like, there's so many people who would love the sign, right? And I think I made that comment out loud, where this guy, he, so basically the idea is that you're supposed to carry your weapon with you all the time. Like they used to have a rule where you don't carry it, and then now they changed it, so they made these signs. Well, this guy turns around and he's like, oh, sir, don't worry about it. If you forget your gun, you just tell them you're a chaplain. So chaplains by like military law aren't allowed to carry weapons, right? So you don't want like the priest out there going around, maybe a little bit of conflict of religious interest if the priest, is on the front line.
Maybe.
So it's like, he's like, sir, just tell them you're a chaplain, or just tell them you're on suicide watch, and then they won't ask you any questions.
God.
Right. And so I was just like, oh my goodness. Yeah. So, this is the kind of environment that was going on over there.
Well, Josh, I have to say, I'm glad you're back in civilian life. It sounds like military life did not suit you all that well, although I'm glad you made it. You made it.
Yeah, I made it. I made it out. Yeah.
Right. Where can people find out more about you, and maybe more about your talk that's coming up?
Yeah, so if they go to cryptotronics.com, which is my company's website, I have a blog post there that talks about the upcoming CCC talk. I think it's right on the front page, and you can go look and see the other CCC talks and kind of get some more information. The talk there's also a website for the talk called wallet.fail. So Dimitri,
nice.
Dimitri got that domain name. So if you just go to wallet.fail, you'll go directly to that. Cryptotronics.com has links to more about us and some of the other the actual stuff we do besides some of the fun antics.
Got it. Any social medias for you?
I am. I mean, I am on Twitter. I have CryptoTX. I have like a love-hate with Twitter. So I don't post all that often there. And I think I'm on LinkedIn. Yeah, so I'm on LinkedIn, whatever that URL is, like /Josh Datko. So if you do the custom one. But yeah, all of this is from the main, if you remember, cryptotronics.com. And then I have a personal blog, which I haven't logged out in a while, but datko.net. I read 60-something books last year. And so if you want to see what books I read, you can go to datko.net.
Oh, nice.
Get some book recommendations.
Yeah, that's great. Especially as the holiday season comes up, that's good for finding books to read. It's always good to
and they all should be in paperback now, so they'll be even cheaper.
Nice. Well, Josh, thanks for joining us, and thank you for telling your stories. I'm glad to hear them again, and I'm sure there's even more the next time we grab a drink together.
Yeah, well, it was a pleasure, Chris.
Great. All right, thanks a lot.
Yep. Later.